Aluminum, lightweight and budget-friendly. What if I told you that one of the most powerful materials on the planet costs less than $1 per kilogram and is sitting in your kitchen right now? That's aluminum. And today, we're going to break down exactly why this metal has quietly taken over everything from your soda can to your smartphone to the rocket heading to Mars. We're talking history, science, real-world applications, and yes, the limitations too. Let's get into it. Aluminum is the most abundant metal in Earth's crust. It makes up about 8% of the ground beneath your feet. It's extracted from a rock called bauxite through a two-step process. First, the Bayer process, which refines bauxite into alumina powder. Then the Hall-Héroult process, which uses electricity to smelt that powder into pure aluminum metal. Now here's the crazy part. Back in the 1800s, aluminum was actually more expensive than gold. Napoleon III served his most honored guests on aluminum plates and saved the silver ones for everyone else. Scientists at the time considered it a precious metal. But in 1886, two chemists, Charles Hall in the US and Paul Héroult in France, independently invented the electrolytic smelting process within months of each other. That single breakthrough caused the price of aluminum to drop by over 99% in less than 50 years, from rare luxury to everyday commodity. One of the most dramatic price collapses in industrial history. Why is it so lightweight? Aluminum weighs about 2.7 grams per cubic centimeter. Steel? Nearly 3 times heavier at around 7.8. That's a massive difference. Think about it this way. If you replaced every steel part in a car with aluminum, you'd cut the vehicle weight nearly in half. Less weight means better fuel efficiency, faster acceleration, and less strain on brakes and tires. That's why car manufacturers, airplane builders, and bicycle companies all love aluminum. Boeing's commercial planes, for example, use up to 80% aluminum by weight. The entire reason a commercial jet can carry 300 passengers across the ocean at 35,000 feet is partly thanks to this humble metal keeping the structure light enough to fly efficiently. And it's not just raw weight. Aluminum has an incredible strength-to-weight ratio, especially when alloyed with elements like magnesium, silicon, or copper. The right aluminum alloy can be nearly as strong as structural steel at a fraction of the weight. That's the engineering sweet spot. So it's light, but is it actually cheap? Yes, and here's the full picture of why. First, aluminum is extraordinarily abundant. It's not a rare resource you have to dig for in one corner of the world. Bauxite deposits exist across 6 continents. Second, and this is the big one, aluminum is infinitely recyclable. About 75% of all aluminum ever produced is still in use today. Recycling aluminum uses only 5% of the energy needed to produce it from scratch. 5%! That's a 95% energy saving. So manufacturers save a massive amount of cost by reusing it, and those savings get passed on across the supply chain. This is why your soda can only costs a fraction of a cent to produce. It's probably been recycled dozens of times before landing in your hand. You drink it, toss it in the recycling bin, and within 60 days, that same aluminum can be back on the shelf as a brand new can. That's a closed-loop system that very few materials can match. Here's something most people don't know, and it's one of aluminum's most underrated superpowers. Aluminum does oxidize, but unlike iron, which forms rust that flakes off and exposes fresh metal underneath, aluminum forms a thin, invisible layer of aluminum oxide that actually seals the surface. It's self-protecting. The oxidation layer acts like a natural armor, stopping further corrosion in its tracks. This is why aluminum window frames from the 1970s still look fine today, why boats and marine hardware use it, why outdoor furniture, stadium seating, and bridge railings made from aluminum can sit in rain and humidity for decades without degrading. Steel needs paint, coatings, or galvanization to survive the same conditions. Aluminum does it for free. Let's talk about where you'll actually find aluminum in the real world, because it's literally everywhere. In transportation, cars, trains, planes, and electric vehicle battery casings are all aluminum heavy to reduce weight, increase range, and improve efficiency. Tesla's Model S uses an all-aluminum body and chassis. Formula One cars use aluminum alloys in their suspension components. In construction, aluminum window frames, roofing, curtain walls, and facades are standard across modern architecture because they don't rust, they're light to install, and they last for decades. The Empire State Building's Art Deco exterior? Aluminum. The Sears Towers facade? Aluminum. In electronics, your MacBook, your iPhone, your headphones, all aluminum. It's lightweight, durable, machines to tight tolerances, and gives a premium feel without a premium price tag for manufacturers. It also dissipates heat well, which keeps your devices from overheating. In packaging, food containers, foil wrap, drink cans, aluminum keeps food fresh, blocks light and moisture, and is infinitely recyclable. The global aluminum packaging industry is worth over $100 billion annually. And in space, NASA's Saturn V rocket that sent humans to the moon used aluminum lithium alloys as the primary structural material. SpaceX's Falcon 9 uses high-strength aluminum alloys throughout the airframe. Even on Mars, aluminum is working. Now, aluminum isn't perfect, let's be real. It's not as strong as steel by volume, so for heavy structural loads, like bridge beams or skyscraper frames, steel still wins on pure compressive strength. Aluminum also conducts heat very well, which is great for heat sinks and radiators, but not ideal for insulation or applications where you need to contain heat. It's also harder to weld than steel. It requires inert gas shielding, precise heat control, and skilled operators, which adds cost in fabrication-heavy industries. And while aluminum is budget-friendly overall, aerospace-grade alloys, like 7075 or 2024, can get expensive due to the precision alloying and quality control involved. But here's the thing. For the vast majority of everyday applications, the trade-offs are absolutely worth it. The combination of weight, cost, corrosion resistance, and recyclability puts aluminum in a category of its own.
So there you have it. Aluminum. Light as a feather, tough enough for space, self-healing against rust, and cheap enough to wrap your leftovers in. It quietly powers the modern world, from the can in your hand, to the plane above your head, to the phone in your pocket. And when you're done with it, it comes back, over and over again. That's a material worth respecting. If you found this video useful, hit that like button. It helps more than you know. Drop a comment below telling me which application surprised you the most. And if you want to see more breakdowns like this on everyday materials and engineering, subscribe so you don't miss the next one. I'll see you in the next video. Peace.